Hello, Namaskar. Let us see the second application. Okay, here application of Gauss law in continuance of that application where we have found out electric field due to linear charge distribution. Okay, here electric field due to uniformly charged infinite sheet. Okay, infinite sheet means very large sheet. Again we have to approach the same sense whether electric field at any point will be effectively due to nearby charges or charges in some finite range. Okay. Large charges at large distance will not influence very much, negligible effect will be there, but it does not mean there will be some significant effect. So, same thing will be here followed. Okay, so electric field due to uniformly charged infinite plane sheet. This plane sheet I have drawn figure already to save your video time, and this is very understandable figure. I have tried for that. Okay, so again this is infinitely large sheet. So we have to take a portion of this distribution, and uniform charge density, suppose generally it is denoted by sigma coulomb per meter square. Okay, and we are able to consider a Gaussian surface here. Suppose the Gaussian surface is projected like this on this surface, shaded surface. So this is shaded rectangular surface element. Okay, shaded part is what? This is a rectangular surface element of the distribution, and a Gaussian surface is projected over this surface element, and it is looking box like. An electric field direction we have to find out, and you have to imagine here, not have to imagine, it will be there. So electric field lines, let us see what should be direction of electric field everywhere on the Gaussian surface. So see here, this is suppose plane sheet, I am seeing from transverse direction. Okay, this sheet is like this in this direction. So this is sheet actually, this is not a wire or not a linear distribution, this is sheet. I am seeing from this side. Okay, so electric field, again we can imagine a point, and in same way this sheet is extended here and here to large distances, then large number of charges are there. Okay, so large number of charges are there, and suppose this whole board is charged. Okay, this whole board is charged, this is sheet. Okay, and then surface charge distribution is there, then electric field, you have to find out electric field at this tip, okay, tip of this marker. And so we have this point where we have to find out electric field, and electric field is this distribution, charge distribution will be what? Due to this charge it is outward if board is positive. So if whole board is positive, then this charge will have electric field in outward direction here. This point is same, this point is fixed here. So this charge on here, forget this figure for this time. So this whole board is charged. So charge in this region will have electric field here in outward direction. Charge in this region of the board will have electric field here, it is in this direction. Okay, charge in this region of the board distribution, okay, will have electric field in this region, okay, like this, and charge in this region will have electric field at this point in this region, and charge in this region will have electric field at this point, this region. So overall outward and here and here, these are electric fields due to different sections of due to different elements of charge distribution. So we can guess what should be electric field, resultant electric field. This resultant electric field is what? Nothing but it is in outward direction, or you can say it is perpendicular to the distribution. So charge here, it offers field, okay, here due to this it is field is here, and due to this charge of sheet field is here, due to this charge it is here, due to this charge it is here, okay, and due to this charge it is now here. And as we go away for distant points, influence of charges will be very small, and it finally for distant points the field will be distant points will influence negligibly, and total resultant field, okay, it is perpendicular to this distribution, okay, this is resultant electric field. So again, no field line is like this or like this or like this or like this, okay, all field lines are what? All field lines are perpendicular to this distribution, okay, here and here and here. So see the figure here, electric field lines will be emerging out, they will be coming out from this face which is parallel to the distribution. This face is parallel to distribution, and this face there will be no electric field line coming out, here there will be no electric field line coming out, or here there will be no electric field line coming out. So only this face and this face on both sides, okay. So electric field lines will be coming out of the parallel faces, coming out of the faces which are parallel to the distribution. So it is easy to calculate now electric flux. So let us consider. So suppose surface charge density is what? Okay, surface charge density equals sigma, okay. A Gaussian surface, a box type Gaussian surface is projected over the rectangular area element, surface element. A box type Gaussian surface is projected over a rectangular surface element, okay, a rectangular surface element as shown in the figure, okay. So it is very easy to refer here, see the figure, okay, element as shown. So from symmetry or from effect or calculated influence, the electric field lines will be perpendicular to the distribution. Since distribution is uniform, okay, electric field lines will be perpendicular to, okay, what electric field line? Resultant, okay, resultant electric field lines will be perpendicular to the distribution, okay, on both sides now. So a surface charge distribution will have its sides. So imagine this is sheet of charges. It does not mean there is some material or not, okay, there may not be some material, only charges, they are forming a thin sheet everywhere, and this is plain sheet. So this supposition is for that. So distribution will be perpendicular to distribution on both sides, okay, both sides, and this value of surface is how much? Its area is delta S, okay. So delta S is the area. So enclosed charge is how much? charge enclosed, okay, charge enclosed by what? Gaussian surface. Gaussian surface is Q enclosed. I used to write this thing En, okay, enclosed. So Q enclosed, or you can write ENC for clarified writing. Okay. So Q enclosed is how much? Sigma delta S. Okay. Sigma is uniform charge density and delta S is the surface, and this is thin sheet of charges, and this field lines are perpendicular to this distribution in this direction and also in this direction. So field lines are emerging from charge and they are going in both directions, here also and here also. So in order to count flux, we will consider these lines and these lines, both lines on both sides. Okay. So this charge is how much? Delta sigma delta S, and flux according to Gauss law. Again, recall that thing I have said. First, due to any distribution, if we are finding electric field, then according to Gauss law you can write total flux. So from Gauss law, from the result of Gauss, okay, what we have to write here? Total flux, phi total is how much? Sigma delta S, okay, sigma delta S divided by epsilon naught if the sheet is kept in free space. So this is total flux. This is calculated one way, according to, it is written according to Gauss law. Now, according to calculation, okay, so first we calculate flux through area element or surface element, d, phi, delta phi, etc. So here you have to not calculate flux from any surface. These lines will be okay. First write, okay, electric flux through a surface element, and we write in everywhere here d surface element ds is how much? D phi equals E dot ds, okay, or delta phi equals E dot delta S. Here in this situation, electric field lines are coming out of the faces which are parallel to the distribution. Okay. In the given situation, okay, in the given situation, resultant electric field lines are coming out from the faces of Gaussian surface which are how much? Which are parallel to distribution. Okay. So total flux here and and here on these faces, okay, E is parallel to delta S also. then total flux, okay. Then total flux from the Gaussian surface is what? Phi equals 2 times E dot delta S. So, delta S is area, surface area of the space, and if we had to find out electric field A, this is electric field, okay. So, here E is what? E is the magnitude of electric field. This is point P, let, where we have to find out electric field. Okay, I didn't mention anywhere here. So, let us write. Okay. So, E is the magnitude of electric field at the given point, P, okay. So, come to this point. So, E is out. Now, we can write here E parallel to, since E parallel to delta S, okay, then phi equals 2 times E delta S. This is total flux and this is equation 2, result 2, this is result. Now, compare these two equations 1 and 2, okay. So, comparing equations 1 and 2, we get what? See, compare phi total here, this is also total phi total, okay, total flux. So, left hand sides are same, so right hand side you can compare here. So, 2E delta S equals sigma delta S divided by epsilon naught, and delta S here it will get cancelled here, and then the result is what? E equals sigma divided by 2 epsilon naught, okay, in free space. Okay. So, see this. So, this is electric field due to infinitely large charged plane sheet, okay. So, this is very simple and this is very important derivation, these both are important. So, hope you will take carefully and seriously. And now, thank you for being with us, and hope you will come to next video with full energy, and till then, namaskar and thank you.